Physics part 223. For acceleration, a is equal to x0 w square sine into w into t, or a is equal to x0 w square cos w into t. Remember that w is equal to 2 pi f, and equations may appear in either form. We got section questions. Number 1, a particle is oscillating in simple harmonic motion with speed 4.5 meter per second and amplitude 3.0 centimeter. At time t is equal to 0, the particle is at the equilibrium position. Calculate for this particle A, the frequency, B, the angular frequency, C, the maximum speed, D, the magnitude of the maximum acceleration, E, the speed at time t is equal to 1 meter per second. A particle is oscillating in simple harmonic motion with frequency of 50 Hz and amplitude of 1.5 meter, rather 15 millimeter. Calculate the speed when the displacement from the equilibrium position is 12 millimeter. Number 3, geologists use the fact that the period of oscillation of a simple pendulum depends on the acceleration of the free fall to map variations of G. A geologist determines the frequency of the oscillation of a test pendulum effective length 515.6 millimeter to be 0.6948 Hz. Calculate the acceleration of the free fall at this locality. Number 4, a spring stretches by 85 millimeter when a mass of 50 grams is hung from it. The spring is then stretched to a further distance of 15 millimeter from the equilibrium position, and the mass is released at a time of t is equal to 0. Calculate A, the spring constant, B, calculate the amplitude of the oscillations, C, calculate the period, D, calculate the displacement at time is equal to 0.20 seconds, G is equal to 9.8 meter per second. Now we've got another section, energy changes in simple harmonic motion. At the end of section, you should be able to describe the interchange between kinetic and potential energy during the simple harmonic motion. Kinetic energy. In section 10.3, we saw that the velocity of a particle vibrating with simple harmonic motion varies with time and consequently with its displacement. Displacement of a particle. For the case where displacement is x is 0 at a time t is 0, the displacement and velocity are given by x is equal to x0 sine w into t, and v is equal to x0 w into cos wt. There is a trigonometrical relation between the sine and cosine of an angle theta, which is sine square theta plus cos square theta, which is equal to 1. Applying this relation, we have x square divided by x0 square plus v square divided by x0 square into w square into 1, which leads to v square is equal to x0 square into w square minus x square into w square, and so v is equal to plus minus w under root x0 square minus x square. If we had taken the displacement and velocity of the equation for the case where the displacement is maximum at t is equal to 0, exactly the same relation would have been obtained. Try it. The kinetic energy of a particle mass m oscillating with the simple harmonic motion is half into mv square. Thus kinetic energy Ek at the displacement x is given by Ek is equal to half into mw square into x0 square minus x square.